Today we're going to learn how to name alkenes,
Cycloalkenes,
and alkynes. All of these organic compounds are unsaturated, meaning that they don't form the maximum number of carbon bonds. This is due to their special bonding. Alkenes have one or more double bonds, and alkynes have one or more triple bonds. Here is the format that you'll use to name them. It always follows the same pattern. First, you'll start with the location of the substituent, dash the name of the actual substituent. If there is more than one substituent, then you'll follow this pattern twice. Then you'll move on to finding the longest carbon chain. Now, once you find the longest carbon chain, in this example it is 6, so that you use the prefix now. So 6 would be hex, and then you state where the double bond or triple bond is found. So in this example, there is a double bond, and the double bond is found at carbon 2. And this is where it starts, so that's why there's a number there. And then you put the ending that shows the reader whether it is a double or triple bond. So "-ine", as you can see up here, represents double bond, and "-ine" represents a triple bond. Let's get into some practice problems. So before we get into this example, I just want to explain 2 rules. So a substituent can never have a double or triple bond, and the reason for this is because you have to always be able to specify where is this special bond, as you can do in the longest carbon chain. Second of all, whenever you have the chance to put a lower number for the double or triple bond, you always want to prioritize that over putting a lower number for the substituent. So for this example, you can see that I've counted this way so that the double bond is in the longest carbon chain on purpose, and this substituent is ethyl. So the final answer is 3-ethyl hex 2-ene. So this example looks very different because there is 2 triple bonds, hence the ending YNE. Now, because there is 2, you have to actually indicate diene. And if there is 3, you guessed it, triene. So the longest carbon chain is 7. So the prefix is going to be hept. And if you had have chosen the carbon chain to be this way up there, 6, 7, that would actually get you the same answer as either way. The substituent is ethyl, and it branches out of carbon 5. So this is your final answer. We're going to start by counting the longest carbon chain like always. 1, 2, 3, 4, 5 is how I've counted, but if you count the other direction, it appears that the substituent will branch out of carbon 3. Of course, the lower number is always better, but in this case that would be wrong, because it would imply that the double bond is in this direction instead of on the bottom. And that's not how it is. It is on the bottom, so the correct answer is 4-methyl-cyclopent-1-ene. Now, it's always important to never forget the cyclo, otherwise it doesn't imply that it's in a circle, and it's wrong. Here is our challenge problem of the day. It includes a double and a triple bond. So let's name this compound. So, we can see that the longest carbon chain is 8. It starts the same way, and then it gets a little different. So, the location of the double bond, we always want to have the lowest one first, because they always go in ascending order, lowest to highest, so that's why I didn't count the other direction. So it's oct 2-en. Now, I didn't make a typo. I didn't include the E on purpose. It's just because it's not the end of the entire equation. So the E is only at the end, not in the middle. So oct, and then the double, this indicates that the double bond starts at carbon 2, and the 6 indicates that the triple bond starts at carbon 3. So it's not really that difficult, but it's a very important principle to know. I hope this video was helpful, and if you learned something new, please like and subscribe down below. Thanks for watching!